Welcome to today's episode, where we dive into the fascinating world of natural language understanding. Joining me is an expert in the field. So tell us, what's this buzz about generative pre-training?
Generative pre-training is quite the game changer. Imagine training a model on a vast ocean of unlabeled text. This is done using a language modeling objective, which essentially means the model learns to predict the next word in a sentence. By doing this, it develops a universal representation of language, which can be adapted to various tasks later on.
Fascinating. So what happens after this pre-training phase?
That's where discriminative fine-tuning comes in. After the model has absorbed all that linguistic knowledge, it's fine-tuned on specific tasks using labeled data. This step is crucial because it allows the model to specialize and achieve impressive results across a wide range of natural language understanding tasks without needing extensive customization for each one.
And how does the model adapt to these different tasks?
Great question. During fine-tuning, task-aware input transformations are applied. This means we tweak how the input data is presented to the model for each task, allowing it to adapt effectively while keeping changes to the architecture minimal.
Speaking of architecture, I've heard the transformer architecture plays a big role. Can you explain?
Absolutely. The transformer architecture is pivotal because it's designed to handle long-range dependencies in text. This makes it incredibly effective for transferring knowledge across diverse tasks, contributing to robust performance.
How does this approach compare to previous models?
It significantly outperforms state-of-the-art models on 9 out of 12 NLU tasks, including common sense reasoning and question answering. The results are quite remarkable.
Wow, that's impressive. What about zero-shot capabilities? I've heard this model has some.
Yes, indeed. The pre-trained model exhibits useful zero-shot behaviors, meaning it can tackle new tasks without additional training. This suggests it acquires a deep linguistic understanding that's beneficial for various downstream tasks.
Are there any auxiliary objectives involved in this process?
Yes, including language modeling as an auxiliary objective during fine-tuning helps improve generalization and speeds up convergence. It's like giving the model a little extra boost.
Lastly, what did the ablation studies reveal about this approach?
The studies showed that both the pre-training phase and the transformer architecture are crucial for the model's performance. Pre-training in particular is essential for achieving those state-of-the-art results.
It sounds like this approach is paving the way for more efficient language understanding. Any final thoughts?
Definitely. By combining unsupervised pre-training with supervised fine-tuning, we're moving towards improved NLU capabilities with less reliance on large labeled datasets. It's an exciting time for the field.
Thanks for sharing these insights. It's been a pleasure having you on the show.